Alright, hello everyone, this is Mr. Cruz. I'm going to go over the highlights of Unit 4 and 5 for Khan Academy for your quiz. First off, it's a mean value theorem problem right here, which means that the slope of this graph, let's say we have a graph here, the slope between these 2 points, there is a matching slope somewhere during this, and that's that C value there. So we just need to find the slope of between these 2 points. So in the denominator of my slope here, I have 5 minus -4, which is 9. And on the top, I'm going to have h of 5 minus h of -4. Now, the easiest way to do that in your calculator is just plug this in here. My first number is 5, so 5 store into x. And I'm going to do x to the third power minus 6x squared minus 10x. So it's a -75 right there. Minus, let's put -4 into x, and I can just pull that equation back up. Right there we go. And 20. So what do I have here? -75 plus 120 divided by 9. I have the slope from here to here is 5. So this line is going up 5 over 1. Now, where's the point on here where the slope matches at? Well, 5 is equal to this derivative, which would be 3x squared minus 12x minus 10. Because that's the derivative there. So now I want this derivative to match the slope. Solve the equation. Let's see here. 0 is equal to 3x squared minus 12x minus 15. I would divide both sides by 3. X squared minus 9. 4x. Let's do 4x minus 5x minus 5x plus 1. Solutions are 0, 5 and -1. And in the interval, 5's at the interval, so it's not in the interval. 0 or -1 is. So that means at this point right here, -1, we have a matching slope. From -4 to 5 here on this graph, at this one point, the slopes match. All right, that's mean value theorem. Set the derivative equal to the slope. F prime of x is equal to the slope is what you're looking for. Twice differentiable function. We have a value here, and what's this mean? At h of -2, we have a point of -2. At h prime of -2, there's a 0 slope here, so something's going on. And h double prime at -2 is a -1, which means it's concave down, so that looks like a definite maximum. Again, that's all of these 3 things are telling you that, and you want to make sure you have in your mind that it's always position, velocity, acceleration. This is a point, this is a direction, this is a concavity, either going up, concave up or concave down, but that's what it's telling you. And if you put that concavity right there with a 0 here, well, then that means it's concave down maximum. Relative minimum, well, that is the first derivative test. So we just find critical points, and critical points are where the derivative is undefined. There are none, but where is the derivative equal to 0? Well, what is that derivative? 4x cubed minus 6x squared. Where is that equal to 0? Those are your critical points. And let's just divide everything by 2 to make it easier. Let's factor out an x squared. X squared, that would be what? 2x minus 3. Double check that. That times that is there. That times that is there. So my points are here. So 0 and 3/2. And then what does the graph look like in between there? Well, you just start plugging stuff in. Let's pick a really large negative. Large negative there squared would be positive. And if I have a negative minus a negative, well, that's negative. So it's going down in this section. It's going down in this section. And what about in this section here? If I pick a 1, that's 1 positive, and a 1 here would be negative, it's going down again. Well, what's it going in here? Pick a really large number. That's positive and positive going up. So for what value does it have a relative minimum? Well, right here you can see it. It goes down then up. So at 3/2. Now let's just take a look at this graph and see what this graph looks like and see if it is anywhere close to what it should be. Let's clear out all these functions here. And I'm going to type this in. X to the 4th power minus 2x to the 3rd power. And zoom 6 standard. And the graph should come down, yeah, right there. Right there at 3/2 it goes low. So I'm going to zoom in. Let's put a box around the key points here. Let's box all this. Box this whole area right here is what I want to zoom in on. Box that. Graph goes down, and see what happens here. It goes down to 0, then down a little bit more. That's what's that showing. Hit trace, and you will see down here at this minimum, about right there, about 1.5. That's 3/2. You should be able to see this in here. Down, down, back up. Down, down, back up. Based on that. And last one, the radius of a sphere is decreasing here, and we have this in related rates, and they're going to give you this formula down here that says the surface area is equal to 4 pi r squared. So that's where I'm going to start. And the radius of a sphere is decreasing at a rate here. So the differential of the radius is decreasing with time at a rate of 4 seconds. So it's going down 4. That's how the radius is changing with time. At a certain instance, the radius is 10. What is the rate of change of the surface area? So I want to find this. There's my givens. There's what I need to find. And there's the equation that relates it all. Well, it's very straightforward. Let's just differentiate with respect to time on all of it. ds dt is equal to 8 pi r. Don't forget to plug in the chain rule here. I brought this down, subtracted 1, but I have to take dr dt. And now what we have to solve for is right there. Perfect. If we plug in everything over here, it'll tell us what we need. So we have 8 pi, the radius is 10, and the change in the radius is 4 because that's given to us. So we have 80 times 4 is negative 320 with a pi. But they'll always give you, well, on the quiz tomorrow, you have the equation given to you. If you don't, you have to come up with this equation, but that's the equation for surface area. All right, this should get you through the quiz tomorrow.